Okay, in this video, we'll take a quick look at onboarding a DBS DECT base station to WebEx calling. What we're going to do here is I'm going to run a live Wireshark capture. I'm going to factor reset a base station I have for it to onboard to a WebEx calling. And we're just going to look at specifically what conversations or transactions occur between the base station and the cloud during the onboarding process. And then we'll do a quick test call. So the way I'm going to capture this, I'm going to filter based upon the MAC address of the base station. I have part of the MAC address blurred here for obvious reasons. So I'm going to concurrently try to factor reset this base station and also start the Wireshark capture. So let me go ahead and there is a reset button on the bottom right corner of the base station. You hold down for more than 10 seconds, at which point you should see the LED turn red towards the top portion, and then we'll let go. And then once that happens, we'll go ahead and start to capture here. These base stations do boot up quite quick when compared to other devices, so we should start seeing some transactions here occur fairly quickly. One thing to note is the base station I have is up to parity on the firmware compared to WebEx calling. Right now we're at firmware 5.1.1 and soon there'll be 5.1.2 firmware. In any case, this base station already is in parity with the firmware, so the one part we won't really see is any type of real firmware transactions, which is fine. But what we're really after here is what is going on from a standpoint, and let me actually go into the conversations. What is actually going on from a standpoint of communications of the base station to the cloud? So we know DHCP was the first phase. Then next phase is going to be a DNS, and then it's going to be reaching out to the different cloud resources. The base station, by the way, does use multicast, especially if you're doing a multi-cell deployment. So you will see multicast traffic occurring. In this case, we only have one base station, so we're not going to focus on the multicast since we're not doing multi-cell. But we will focus on is what transactions or conversations is the base station having with the cloud. So far, we have two public addresses of conversations. We have 72.163.15.184, and also we have the 199.59.65.228. And what I like to do is if I'm troubleshooting where there's an issue with onboarding a 3PCC device, in this case we're focusing on a base station, I like to do this type of Wireshark capture and then do a comparative analysis with the WebEx calling port usage document. In effort, I can see exactly what is occurring. I can also take these IP addresses and do a quick search, Control F. In a port usage document, typically I'll put the first 3 octets in. If it's a larger subnet, maybe just 2 octets to figure out what's going on. Also, I can put these public IP addresses in ARIN, the Authority for North American Internet Registry for the numbers. Just to make sure that it looks as it should as far as resources that belong to Cisco, to WebEx, and or AWS. That's typically what you'll see. So right now, actually, the base station is finished booting up. Let me take a look at my actual DECT phone, and let's see where we're at. Okay, so let me go ahead and register the DECT phone. Okay, I'm going to go ahead and need to type in my access PIN number, so access code. Let me check really quickly. So what I'm doing right now, it's off camera. You guys don't see it as I'm logging into WebEx Control Hub. I am going to the calling section on the left side here. And then top center of the page, I'm going to features, and then I'm going to DECTnet, and then I'm finding the DECTnet this base station belongs to, and I'm looking at my default access code. Okay, so I'm going to punch it in here. Okay, I'm going to hit OK. Okay, now it's going through the registration process. Okay, it's registered. Okay, so I'm going to do a quick test call here. from the DECT phone to one of my desk phones. Both phones are on WebEx Control Hub. One of the phones is a 8845, and then the DECT phone I have is a 6825. So let me do a quick test call here. Okay, I'm going to let it ring for a few moments so you guys can hear it. Okay, I'm going to go ahead and answer the call here. Testing, testing, testing. And what I'm going to do is, let me take a look at the UDP traffic here. So we'll see some of the numbers here increase quite a bit. If you notice right towards the bottom here, the traffic is encrypted, so we can't really analyze the payload, if you will. But if you notice, a lot of this traffic here is going to be UDP. So let me go ahead. I'm going to move the phone a little bit away from myself so it's not too much feedback here, but I'm going to still keep it going here so we can take a look at it. But if you notice the pattern, transmit, receive, transmit, receive, there are also adjustments you can make in Control Hub as far as QoS for the DSCP, expedited forwarding. What you'll notice is from the cloud itself. So let me go ahead and I'm going to go ahead and end the call here. And then I will go ahead and let me stop the capture here just for a moment so we can take a look at this. So let me stop the capture. So what you're going to notice here is the traffic coming from the phone itself is marked EF, expedited forwarding. So if we take a look at the header of the IP packet, we'll notice right here that it's marked. By default, the traffic coming from WebEx Control Hub is not marked. There is an option you can enable QoS for it to be marked. The one thing to note, there is no QoS on internet. It is best effort. So generally speaking, from an internet standpoint, it's really not going to make any difference as far as your own network. If you're doing QoS type of deployment where the switches or devices, generally switches, routers, firewalls, that they're actually looking at the DHCP markings and based upon that, doing priority queuing for the VoIP traffic, perhaps there can be a benefit there. But let me go ahead and remove the UDP so we can kind of wrap up this video. So if we go to the very beginning here, at the very top, which is right after I did a factory reset. So if we go down here towards the bottom, so we have a lot of CDP information here that's happening. Then we have a DHCP request. Then it's going to get a IP address. Once it establishes an IP address, it's going to start doing a lot of DNS activity, kind of what we see here. And then it's going to basically transition. So most of the onboarding process is done via TCP, and then very quickly it's going to transition over to being TLS encrypted traffic here. So it's kind of go down the list here. We'll notice it'll get to a phase where we'll start transitioning towards TLS type of traffic. I'm just going to speed it up a little bit here. And this is where actually I get into the actual phone call portion of it. So let's go back to the part where it does a listing of all of the IP addresses, then we'll look at the ports. So I did some other videos that I do this similar thing with the non-DECT phones, just the standard 3PCC phones, and you'll notice the amount of communications that the DECT phones have is a lot less compared to the standard 3PCC desktop phones like the 8800 phones, etc., etc. So are they the same? They're not exactly the same, and this is where if you look at the WebEx calling port usage document, you'll notice they cover quite a lot of information, and the reason being, depending if it's a 3PCC phone, if it's a room OS type of device like a video conferencing telepresence device, if it's another type of device like an ATA, a DECT, etc., etc., there may be certain variations. So these are all the different public addresses that the phone was communicating right here. And again, we can reference this with the WebEx calling port usage document, the TCP transactions right here. So a lot of port 443, as I was mentioning, TLS type of packets. And then the UDP, we have DNS obviously, but then also from a RTP standpoint. So if you notice, this guy right here has a lot of packets. This 199.19.197.123. Almost 6,500 packets. So that's mainly where we're doing most of the RTP traffic. Other than that, we can also look at some of the packet sizes. So if we go up to packet lengths and take a look at this. So one thing to note is if you're having onboarding issues and you've spent time looking at the security devices, firewalls, web content filtering, etc., and you validated none of the stuff is blocking the packets of the telephony equipment to onboard and function with WebEx calling. The other potential area that can trip stuff up, they may not be obvious, is if in the pathway there's any types of issues related to larger packet sizes and or fragmentation. Typically we would want to see, look at the MTUs. If there's any issues, if we're hitting a certain MTU size and the fragmentation is not working quite right and it's having the issue the same, so that's layer 3. Layer 4 TCP maximum segment size. In this case, this example, there is no issues, but something to be aware if you have a very advanced network deployment, a SD-WAN, MPLS, there's site-to-site VPN tunneling going on, etc., it's very easy to run into a situation where something is really hidden and things are kind of working for most of the other stuff that's deployed, and or people have put in maybe band-aids to get around issues, and you go in to do a deployment of onboarding phones to WebEx calling and you start running into odd issues. You spend quite a lot of time analyzing the firewall rules, etc. You really can't find anything that's blocking. The next thing really to consider focusing on, well, one thing I should bring up is easy test is go ahead and take the base station and the DECT phone home to a home network and just do a factory reset and see if it onboards. Typically, a huge majority of time it's going to onboard no problems. It'll work just fine. And try to do a wire short capture. Make sure you have PoE. If you have a network tap or a switch that, a manageable switch mini one, you can do port mirroring because you want to capture that evidence. Then come back to work and or the network you're deploying and do a comparative analysis. Plug it in without doing any factory resets. Does it function? If it doesn't function, it was functioning at home, then definitely not only can it not on board, but it was just functioning in your home network. You brought it at the site in. The phones that are registered to WebEx calling are very portable. As long as you have internet access, PoE, and there's nothing interfering with it, and obviously you have enough bandwidth. Generally for like G.711 calls, each one of those calls typically uses something in the 80 kilobit per second range. You want to also have some headroom. But in any case, it's a very easy test because if the issue stays with the site and not with the equipment, then definitely something with the site is interfering. In this case, the largest packet sizes we had were 1514 right here. And then if we go up here and we do a sort based upon the length, and I'll go to the bottom here. Okay, and if you notice there's some fragmentation occurring right here. Generally speaking, when you're onboarding, if you run into issues, what will typically happen, it's related to fragmentation and or MTU and or TCP maximum segment size types of issues. What you'll see is you'll see the phone to basically do a TCP connection, and the packet size will be a little bit larger in size, typically in the 1400s or low 1500s, and then nothing will come back. And then a phone will try to do another connection TCP. Nothing comes back. It'll try that a couple times and then it'll give up. And typically the phone may go quiet for X amount of seconds or a few minutes. Then it'll try it again to do the connection. So you'll see this rotating pattern of this issue reoccurring. The other thing we can take a quick look at is going to be the VoIP packets here. The packets are encrypted, so we won't be able to actually listen to the payload. But one thing we can do is, if you notice within a phone call, and the same thing applies to video calls, like video conferencing calls, if you will, with video endpoints and or with telepresence units, is it's going to be a bidirectional stream, duplex, transmit, receive, concurrent. It'll be going back and forth. So initially when a call starts up, it'll be one direction, and then when the call is established, we'll see a bidirectional effect here. So what we can do, since this is encrypted traffic, by default, Wireshark is not going to identify this as RTP or secure RTP traffic. We just see it as UDP traffic here. So what we can do is we can right click, we can do decode as, and then we can come up here, we can just click on that column RTP, hit enter, and then we can hit OK. And you'll notice now it's being identified as RTP traffic, G.711 MULA, which is most common for North America usage. And then we can go up to the telephony section, and we can take a quick look at the RTP information offer. So we can go in here, we can see what RTP information is being listed right here. We can do analyze, and this will give us some additional information we can look at. This definitely can be useful if you're troubleshooting audio. There's also statistics within WebEx calling you can leverage. The one thing to be aware is, since the traffic's encrypted, you won't be able to necessarily listen to the audio. And the second thing is that the captures are larger in size. What I found over the years is this component of Wireshark may have some stability issues. So if you're clicking around here and it's a larger capture, you may want to pace yourself, otherwise you may see some unexpected crashes at times. Any case, hopefully this video has been helpful regarding an example of what communications at a packet level looks like when you're onboarding a base station, a DECT base station, to WebEx calling. Thank you for watching the video.